In episode 4 of MobiCast, John and Chris introduced me to continuous integration and deployment. Welcome to MobiCast, a weekly conversation about containerization, Docker, and modern software deployment. Let's jump right in.
We've been talking about how Docker is not just a technology choice for running software in production. It's not just, let me Dockerize that and put it in production. That's not really the goal. In the last 3 podcasts, we've talked about how Docker really touches the whole life cycle of software development, from dev to test to demo to production, and that it influences decisions that you make in every part of that. So your CI/CD pipeline before Docker is going to look entirely different to your CI/CD pipeline after Docker. So I think I just want to hand it over to you, Chris, and you can take a shot at giving kind of a high-level overview of what we do, and then we might start diving in. So you can talk about what we do in dev, what we do for automated testing, and then what we do for deployment, just kind of at a high level, and then we'll figure out what makes sense, just get in there for each of those and dig a little deeper.
Sure. Yeah. Thanks, John. So at the, the highest levels, it's the age-old problem of developer writes some code, needs to get it tested, and then somehow get that actually out there in the hands of users, whether it be shrink-wrap software or cloud-based software or whatnot, right? So what does that whole process look like? And it's definitely evolved over the years, for sure, as the tools and technologies have gotten better and more sophisticated, as the community has focused themselves more on automating more steps and placing resources and efforts in those types of areas. It's definitely matured. So again, a wide range of possibilities there, but at the kind of the major steps along the way are a developer. I'm writing code. I'm making changes. I'm self-testing myself, kind of assuring myself that this is good solid code. I now want to include this with the product. So I'm committing that to my source code system. After that, I need to build artifacts. So this could be, if it's compiled software, it's producing binaries. If it's dynamic, a dynamic language, it still may need to pull in dependencies, and it may need to go through steps like transpilers, and it may to go from an intermediate language to a first class language. And then once those artifacts are built, then to get those distributed, right? So that's the deployment part. So definitely various phases along the way. So you need to build your code, you need to test your code, and then you want to deploy your code, right? So that's the overall process framework, and you can automate as little or as much of that as you want. And we definitely have gravitated more towards automating as much of that as possible. Mostly, well, I mean, there's lots of benefits, right? Some of the obvious benefits is that it's faster. It doesn't waste developer time to have machines do this stuff. So that's a big factor in it. Also, repeatability and consistency of builds. This is something that we can go into more depth as well. It's definitely one of the big major advantages of having a repeatable build process, where you always have a clean slate when you're making these artifacts, and you don't have to worry about it being polluted with perhaps inconsistencies on one machine versus another one. So having a pure state as you build these artifacts is pretty important. So
just quickly jump in. I realize that you're talking about automating these pieces of the build process and the development process, and I think that's really the C of CI/CD. So continuous integration and continuous deployment. Making it continuous is automating it.
That's definitely a big part of it. It's also part of the philosophy of how you actually build code. So before, like, the term continuous really kind of came into the common parlance, a lot of times what would happen is people would go, teams would be isolated, and they would spend a lot of time separate teams working on their code base, their individual features. So like perhaps one team was working on a set of APIs, another team was working on consuming those APIs. They would all work independently. They'd have their own, potentially their own source code repositories. And so they go through, it's, more like the waterfall process of like, we're first going to do our architecture, then we'll do a design, then we'll do our code, then we'll do our testing, and then we'll do our integration. And so that integration part, that's where a lot of folks just realize that this ends up causing like this huge problem. Like you develop these things, you made some assumptions, and then if you try to verify those assumptions, by the time you go and you're ready to integrate, it leads to a whole bunch of problems. So this idea of continuous integration is you're constantly in that integration process, right? You're constantly committing your code back into the main repositories, and everything is just so you get rid of that separate phase of integration, if you will. And yeah, you have to have the automation in order to support that.
Cool. Yeah. So that was a bit more of a tangent than I thought it would be. So let's go back to, okay, so you just described at a high level what it is, the three main things that we're automating. We're automating, what developers do, what happens in test, and what happens in deploy. And then you described that doing that continuously is the reason that there's the C in front of the CI/CD pipeline. But then I wanted to get into what is Kelsus doing? What are our tools of choice, what is our process of choice for doing this?
Right, and so we definitely have our tools and processes in place for each one of those steps. So as it's obvious we're definitely behind Docker, and Docker is our definitely a big part of our tool chain for building our Docker images, which at the end of the day that is our artifact, our build artifacts that we need to build. We are using a continuous integration system. There lots of them out there. The one in particular we're using is Circle CI. There's plenty of other ones out there, some open source ones as well as many paid ones as well. We really do like Circle CI. Integrates very nicely in with our source code repositories, which is GitHub, like most of the rest of the development world out there. So that when developers make commits to their code, and they merge it into and they push it to the remote repo, so they push it to the shared repo, there's a webhook that Circle CI integrates into, and then it knows that a change has been made, and that causes it to kick off a build process. So you can have a description file that kind of tells Circle CI how to go build your artifacts, and so it will do that. And for us particularly, in addition to building the artifact, that's where we run our unit test as well in an automated fashion, right? So after it goes through, it builds the Docker image for us. It then will run a suite of unit tests, and if those unit tests pass, then that actual image is then stored for in our repository. That's now available to be deployed. If it fails the unit test, then we receive a notification that this is a bad build, and that means that we now have to go and look and figure out, okay, well, what happened here? Why did it fail the build process? Why did it fail our testing?
I think Rich, you had a question about that failed part.
Yeah, so I guess to make the question a little bit more broad is like, what kind of tests are you putting in there? Because what I've seen from a few projects is that there's an inevitability of that test failing. And it seems that depending on the type of fail, that sometimes people will push anyway, right? So because it was a really opinionated thing that really wouldn't break anything. So can you talk a little bit about sort of what happens when something fails, especially when you're on deadlines?
Yeah, that's a great question. As far as like, what do you test, right? What does that include? It runs the gamut, right? Like having good test as part of your process it's a very difficult thing to do. It's one of those things that for better or for worse, most developers just don't like doing, but they are truly valuable, right? I mean, having good test cases spending the time to do them, kind of, it's an investment. You're building up your bank account, that's going to have compounding interest for you in the future, right? Because by having good test coverage of your code base, as your code gets bigger and it gets more complicated, those tests will pay off in dividends, because it's going to alert you if you have these side effects in the code, like especially as you have new developers work on it, right? It's one thing if you have the same developer that spent, a year or two on the same code base, but if you start bringing on new team members and it's a large code base of 100,000 plus lines of code, they're going to be concerned if, like, the code they're changing, like what are are there side effects? Am I breaking anything else? So by having good test coverage in there, it gives a lot of peace of mind and just insight, and knowing that the change you're making is going to be working the way that you expect it to. So it's definitely, it's a very big topic to say, like, what amount of testing is necessary. It's definitely a big topic to talk about, like, what types of tests you want to have. I'm definitely a big fan of, you need to have a core set of test coverage for your code base. And if you are writing tests for your code base, and if any of those tests fails, then you have a big problem, right? Your build has failed, and so you cannot deploy that unless you actually fix those problems. I think it may get confusing. Sometimes people may have, like, tests that are brittle, and kind of lead into some of the issues that you kind of talked about there, Rich, where perhaps they don't really reflect true errors. It may be, something else changed. So now the test is bad, right? So tests can go bad, right? Tests can get out of date. You can actually have technical debt associated with your test cases, where if you change some code, so the code works differently now, and that is by design, well, then you have to go change your test. And so that sometimes ends up becoming a big problem, especially on projects that have been around for a while.
I think I can pull this together a little bit, because one thing that I know that Rich is getting at is a project that he and I worked on a long time ago, where Kelsus actually took this project over from another company. And when we started, one of the first things we heard was, "Oh, don't worry about those tests, that are failing, because just ignore that." And that, I think what we're getting at and what we're saying is that is a non-starter. Like, get them out of the test suite, fix them, do something, but it's never an okay answer to say just ignore those failing tests. That you're already starting in just the worst position possible. You might as well not even have them. What's the point of having any tests if you have some that are failing that you're told to ignore? Because then somebody that's new, that doesn't know the project very well, heard someone else say, "Oh, just ignore those failing ones," and maybe way back there were 3 specific ones that were failing and all the other ones were supposed to work, but the new person doesn't know that there were 3 specific ones that were supposed to fail, and she sees 6 of them failing and is like, "Oh yeah, but some of these are supposed to fail," and now you've got 6 failing and there are only supposed to be 3, and like, you're playing operator. Nobody really knows what's supposed to pass, and it's just not okay. It's just absolutely, you can't work like that, not professionally, in my opinion.
Yeah, and I think that it kind of brings up this broader question of, do you start with fewer tests and not make assumptions on what you need to test, and then as things become more complex, you start to introduce new tests, or being proactive and saying, maybe it's through your own experience or the fact that you just, as a developer, over engineer things, that we should anticipate this breaking and therefore we build it into the test?
Yeah, I mean, it's again, you're going to ask 10 different people and you're probably going to get 10 different philosophies. Me personally, I'm pretty much a fan of tests are very valuable. I do like to see as much test coverage as makes sense, right? So, like, I'm not saying that you have to have 100% test coverage, because a lot of times, that extra 5% is perhaps silly stuff like configuration files, or loading in a descriptor file, something of that nature, right? So you have to use your judgment, and this is where when you do have test code running, that you want to have the insights into, like, what the coverage looks like. So you definitely want to have code coverage tools, right? You want to have reports that are generated every time your tests are run to show you exactly what your test coverage is, like which parts of your code did get tested, and what percentage is not being tested, right? So that's your code coverage rate. You definitely want to eyeball that and ask yourself, are the most important code paths being tested, and do I have good tests for them? And so, if you're in a situation, a legacy system where like you have test code that you're not really sure what state it's in, or there's lots of failing tests, one of the obvious things would be just come in and say, just rip, just get them all out, burn it to the ground. And I'd rather start from scratch, right? And say like, we're going to write some good tests. We'll start off with, call it 20% test coverage, and then that will be an ongoing work item to increase that test coverage. Have very good tests. Be very mindful and have the insights into what paths are actually being tested to make sure that the most important paths are being tested, and then to iterate from there.
And to bring this back to the Kelsus CI/CD tool set, the reason that I thought this was a good time for you to ask that question, Rich, is because Chris had just gotten finished saying Circle CI is going to run its tests, and then it's either going to make an image to put into the repository or it's not. And that's the technical component of this that enforces the process. So it'd be one thing if we said, no failing tests, and that's just our rule. And it's another thing if we just actually automate that rule. And that's, I think, what Circle CI helps us do. And please correct me if I'm wrong, but I believe that if tests pass, we don't get an image up on the other end that we could end up deploying to staging or production. You just get nothing. There's nothing you can do. The test failed. Your build failed. Better go fix them if you want an image that you can use to do something with. And that way, there's no manager saying do this or that. It's really just the software itself is saying, oops, go fix something.
Correct. Yeah. The way that we've set up a process now, it's very difficult for someone to deploy if it has failing test. That said, people can always turn off the test, right? So there's things around that, but absolutely, that is like it's baked into the process. It's right. It's really like, how do you want to conduct yourself as an engineering organization, and just realize that like if you start going down this path of like making these exceptions and saying, oh, we got to get this done quickly, and we know that there's issues with it and we're going to circumvent our process, then you have to start asking yourself some hard questions, like why even have the process to begin with if I'm not going to follow it. There are tremendous advantages to having that process in place. It makes more sense when you have a team of more than a couple of people. If it's just one or two developers, then you may not want to have such, to have a more defined process like that. Although, like me personally, I would still be a strong advocate of that. I don't think that there's any reason why you can't kind of adhere to some of the like just basic things to say like, I'm going to have repeatable builds and I'm going to have automated tests and I'm going to, have my test cases pass and do my deploys.
Just about the only case that I can think of where I think there's a really good business case for not doing something more strict like this is, say, for example, you got into Y Combinator, you've got 3 months to produce something that does something, and you know that you're going to get funding after that if you're successful to go do something the right way. Then maybe you don't write any tests during that 3 months. You just hammer out some code and try to get something working, and you might be able to go a little faster if you know what you're doing than if you were to already do everything sort of the right way. I think though, in that like little tiny niche of software where you've got very, very little budget leading to more budget and a rebuild later, that might be the one case where I would suggest against doing this.
Yeah, absolutely. Call it a prototype or something like that. It's something where you just have to go, really, really fast. You're not really engineering, right? This is really just proof of concept, and you're trying to demonstrate an idea. And you do need to go fast, but knowing that like this is not the final solution.
That actually brings up something that I think that I'm a little bit confused on. And I don't want to derail this conversation, but really quickly. So I have this picture in my head of, you're writing code locally, and then you're pushing that to a repository, and that's going to send off a webhook that's going to go to the CI, right? Like Circle CI or something similar. But even when I'm running are writing code locally, there are a lot of things that I could be doing and probably should be doing that are also running tests, right? Like I could literally be writing my code with test-driven development. A lot of the packages that I install for my dev suite are going to run some tests. So, like, is CI all of that, or is CI literally? Are we talking about just that thing that exists? It's like maybe not technically middleware, but something sitting in between my server and my repository, or is it this whole entire process, including all of the packages that I install, like JSLint and Codeception and all of those other things?
Yeah, I mean, there's probably a couple different philosophies here that they're all kind of falling under the umbrella of what we're calling like this CI/CD pipeline, but it really is kind of at the basic level. It's what is your engineering process, and how do you go about conducting yourself? Again, the continuous integration part of it, that's less tooling and more process. It's really about like, what is your development philosophy? How are you actually committing to your repos and collaborating with everyone else on a larger software project? So if people are committing frequently and syncing up and merging into a shared branch often, like basically daily, then that's definitely a big part of continuous integration, right? You could be using Circle CI, like a tool like Circle CI, which is, the CI stands for continuous integration, but you could actually use it in a way that you're not doing continuous integration whatsoever, right? You could do it in a way, you could just use it as a build machine, right? So good engineering processes, like the individual developers, as they're developing code on their machine, they absolutely should be running those exact same tests that the build machine is going to be running, right? So it really should be like very rare that tests fail on the build machine because they've already run it on theirs. Now it may end up on the build machine. It pulls in other parts of the project and it does more advanced. Maybe it does even starts getting into like integration tests where you're testing the interfaces between multiple subsystems of your code, and then problems may surface. But the actual like core unit test, that stuff should be run by the developer on their machine. Things like lint tools, that should be baked right into the whole build process as well. So like the developer, in this case, we're using Docker. They're going to be building a Docker image locally on their machine to do the local testing and to run it and verify things are working. As part of building that Docker image, it should be going through a lint process. So things like code style should be enforced, and kind of like the silly kind of like typo type errors would be caught, especially for the dynamic languages that aren't compiled. All that stuff would be caught locally before the commit is actually then made and merged. We haven't talked about things like other parts of the process, like code reviews and having peers review your code after you've done your local development and testing. Then you have your peers look at the code and eyeball it, and to see if they can find errors, or they can learn from it. They may know about other parts of the system that you didn't and have advice for you, or they may have just sharing experience, and they may have different suggestions for improvements to the code. So that code review process is part of that, and then all of that happens before you even commit the code, right, to the remote repo, which then kicks off the build process with Circle CI, right? So there's still a lot of steps before you even get there, for sure. And a lot of this is duplicated, right? The build machine, the Circle CI process, that should be reinforcing. It should be duplicating a lot of the stuff that the individual developer did, but now it's being done on the Switzerland of a machine, if you will, right? It's not tainted, it's fresh. It's you don't have to worry about it being polluted with having like some old software on it or some additional software put on it. It's a fresh, neutral machine, and it's going against exactly what's been checked into your code base, and it's going to basically guarantee you that like everything that needs to be checked in has been checked in. The code is solid, it's passing test, and that's why you need that machine then to go build your code and publish that as an artifact.
one thing that I don't know, because I just haven't been doing development myself since we've taken on this process, is so Circle CI, it's going to use a build machine. You were just talking about it's the Switzerland build machine. And I know that eventually, our goal is to get the application that we're developing or applications or microservices onto a staging environment and then a production environment. And then, based on our conversation last week, I know that the staging environment and production environment are actually ECS clusters, and that there's probably some databases that are on RDS, which is another AWS tool. And that those are big environments that we, at least at the moment, are still manually setting up. We'd like to get to the point where we're using CloudFormation or Terraform to set those up, but I think we're still setting those up manually. My question is, for Circle CI, what is it using? Is it building on some other machine and then deploying to one of those environments to run its tests, or is it doing everything on a single machine? What is the relationship of what Circle CI uses to those environments that things are going to eventually end up on?
Right. So Circle CI itself today uses Docker. So it's actually spinning up Docker containers in which to build the code and to test it. At least you can actually set it up to do that way. Before in the past, it actually had its own custom container system, and I'm sure before then virtual machines was the way to go, right? But because obviously a company like Circle CI, they're not going to give you a dedicated wipe the disk on a bare metal machine each time you want to do a build. That would take forever, right? So that's where this is it's like meta. Here we have Docker is great for us for developing our code and hosting it and deploying it and really kind of isolating it as this separate unit that is kind of pure and contained. And that same philosophy works great for like these continuous integration build systems. They're going to use that same technology.
Okay, so then Circle CI is going to build a Docker image, and then it's going to run it, and then it's going to run the tests against that Docker image. Does it have its own test runner kind of Docker image that's running those tests, or do you create a test runner Docker image and tell it use this?
There's a lot of flexibility there. So there's systems like Circle CI. They can recognize languages, right? It's pretty straightforward to being I can see that this code's Python, or I can see this code is JavaScript or Java or .NET. And there's certain conventions. A lot of these languages, right, have certain conventions of like where tests go and how tests are defined and configuration files for those and various test runners. So just out of the box, there's a lot of times where Circle CI, you have to tell it anything, it will just kind of know how to go run test, right? And it'll try to do that. So if it'll go and look for the places where it thinks where it expects tests to be for the language that it's detected that your code is, and it will go try to do it. You can do that, or you can be much more explicit, which is what we do at Kelsus, right? We actually give it some instructions and we'd say, this is exactly how we want you to run tests. Like these are the commands, right? So we're actually being just much more declarative and having control over that and saying, we want you to use Mocha as our test runner, or we want you to use Jest. And this is how we want you to create code coverage reports. We're going to have you use Istanbul for our node projects to go create these code coverage reports.
So there's an application that's running inside the container that Circle CI built, and that's the application under test. Is Circle CI all giving commands to the Docker container to say, hey, also go do this? It's saying go do, there's already a process running inside the container, but it's saying run these additional processes inside the actual container under test. So the tests and the application are all running inside the same container.
Yeah, I mean, you can think of is your build machine is being spun up on demand, triggered by this whole process, and that build machine is a Docker process, a Docker container, and so you now have this. It looks to your code and to everything else, it looks like it's just a brand new, fresh machine that is just running, and it's just as if you were developer were doing stuff. So you're doing like Docker build. I'm building my Docker image, and as part of my Docker image, maybe the image itself has some. That's where I do linting, right? So that just kind of happens. And the result of that is some exit code, right? It's either successful or it's not. And if it wasn't successful, then it just says, okay, I'm done. This entire thing has failed. Shut down the container and report back, right?
Okay.
Above, right? If it's not, then again, you can tell these systems like Circle CI like what to do. Like, so after you build a Docker image, then I want you to run the test, right? And this is how you run the test. And so to run the test, you're actually now going to do something like a Docker run command. So you're going to run the image that you just built to now execute the tests that were included in part of that as part of that image. So that process goes right, and part of that might be it's doing some commands now to execute the code coverage reports. And so it's just kind of up to you how much, what you want that build process to look like, how much work it's going to do, but it's all happening inside of that Docker container that Circle CI is spinning up to basically host this whole process to make it look like it's on its own separate machine, when in fact it's just running inside of a container.
Got it. And what about, some dependencies that the container might have, like especially a database? I think that it gets sort of ridiculous to have to mock up all of your database interaction. It's probably better to just assume that there's a database available when you write unit tests that may end up touching a database. So what do we do there?
It's a great question. This is another one of those holy war issues.
Sure.
Right?
You already know my opinion a little bit.
Because you will have people that are pretty adamant that unit tests don't have any dependencies whatsoever, and if your test cases are causing your code to go make database calls, then it's now an integration test.
Right.
Then you have to go down the path of, well, do I mock out my dependencies or do I not? Right. And so there's tons of code out there for mocking stuff. There are intermediate steps. And so one of the things that I really like with Docker, it's a great use of the technology, is I can kind of mix that gap between unit and integration tests. So I may very well, especially if I'm writing a microservice, and some of my my endpoint implementations for implementing these RESTful APIs, it may very well want to go, talk to a database in order to do its work, especially for doing things like queries and whatnot. So I'm not a huge fan of like mocking that stuff out, and I'd rather just use the database itself. So one technique that I really like a lot is just use the power of Docker to spin up another container that hosts your database, have a test file that you can use to seed your database if you do want to have some existing data. So you can take a snapshot of a staging database or a production database, just have that available for it, and use that as the seed for your database that just gets spun up. It's totally ephemeral. It only lives for the duration of those tests, but your code doesn't know is none the wiser. So it can go do those tests. It's all running inside Docker. It doesn't take a lot of effort. You don't have to worry about keeping like this whole separate environment and make sure that that's up and running and have that kind of dependency, and the way you go.
Great. I think that's that's sort of what I expected. I wasn't sure if we were putting the database into the same container as the one that is built for tests, or if we were pulling in a separate container. And I like that we're pulling a separate one, because it just makes sense. That's Docker doing its job and having each process be its own container.
Yep, absolutely.
Okay, so we kept it at a real high level. Like, this is what the developer is doing on their machine. They're writing code, they're linting their code, they're running the unit tests, which may include some integration tests. Then they're sending that over to GitHub, which has got a hook in it that tells Circle CI to do some stuff. And then we just did a little bit of a deep dive on what Circle CI does while it's running the tests and how that works. And then also what our tests actually do. So then, assuming that the tests pass, what happens next?
So the answer is that depends. This is where we start getting into the CD part of the acronym. So continuous deployment. So yeah, what do you do after you actually make your artifact? You test it, passes all the tests. Definitely, usually the next step is you're going to publish that artifact. So you're going to publish that to your repo, your artifact repo. For us, since we're on Docker, that means we need a Docker image repo. And since we're on Amazon, we're using ECR, which is the Elastic Container Repository, which is essentially just a directory of these images that are now available for containers to pull as they need them. So that image will get published, and then after that, we have to decide if we want to do a deployment, right, automatically. Continuous deployment, again, one of these, can have some interesting philosophical discussions. My personal opinion on this is that to do true CD, there's a couple prerequisites that have to be in place. One is that you need to have very good integration test coverage. And then the other thing is that you need to have built in the sophistication for doing rollbacks very, very easily and very quickly. We've taken a hybrid approach at Kelsus where we feel comfortable in our dev and staging environments, even though we don't have those two things in place, that we do have the deployment, continuous deployment enabled for those particular environments because they're non-critical. And the truth of the matter is that that is where basically integration happens, and a lot of the testing does happen. So to deploy automatically there makes sense for us. For production deployments, it's not an automatic step. So that's something that we've not set up Circle CI to do. Instead, it's a manual process. So someone has to manually make that decision that this particular image is indeed ready. It's been verified. It's passed all of our tests. We feel very confident that this is ready to be promoted to production. And in which case, then it's a very quick manual step by the person doing that deployment to make that promotion.
Knowing a little bit about how this works, I know that we use the power of GitHub and Git and branching for this. So maybe you could tell us a little bit about how we've set that all up.
Sure. Yeah. So Circle CI, one of its features that it has is you can set up branch specific actions, right? Based upon what branch the code has been committed to in your actual Git repo. So we have specific branches in our code base. We've come up with a kind of a convention that will have we have one branch that's known as development. There's another one that's known as staging, and then we have master. So we tell Circle CI whenever there are code check-ins that are against either the development branch or the staging branch to go ahead and deploy automatically to those particular environments, right? So there's scripts that we have that get run by Circle CI when those branches are run, and that those scripts essentially are basically just saying, okay, I'm going to go and do the things that I need to do to tell AWS to update ECS to now run this image there in that particular environment. So it's done on a branch specific specification that is just a feature of Circle CI. So it's a very nice feature to have. And so that's the convention that we've employed is having specific branches in Git and then having certain instructions, Circle CI, for how it should go ahead and do deploys.
What about if there are database changes as part of a commit?
Man, you're asking all the hard questions today, John. So database migrations is a whole nother can of worms on this as well. It's one of those things that's actually it's very much specific to the language that you're working in. So in the past, I've done a lot of work with Python and Python's technology. One of the common Python ORMs that we use there is called SQL Alchemy, and SQL Alchemy had a different component to it called Alembic, and Alembic was this technology that would create your database migration scripts based upon your model changes in your code base. So the developer is working in their Python code base. They're changing a property on a particular database model, like for a it's called the customer model, right? So they're adding a middle name property on the customer model. So you run this Alembic tool after you make your code commit. It can then see that, oh, you've changed something, and so to your actual database model, and its output is a database migration script that now includes the actual commands that you have to do for the particular database that you're using to say, hey, go add this new column to this particular database table. So it has that script. It also has the features inside that to now run that script against an actual database. And so what we did there would be when code is deployed as part of its startup process, it would go and run any available migrations for it. So these migrations would be versioned in with the source code. They'd be baked into the Docker image, if you will. And so when the Docker image gets run, it's going to go and using Alembic, go figure out, okay, what is the last migration that was run against this? Do I have something that's newer? And if so, go ahead and run that as a transaction, basically under a mutex, so that that will be run once and only once. And then if that succeeds, great. We now have the migration that's automatically done for us. If it fails, then that whole deploy has to fail, right? And then you have to be able to, because that was run in a transaction, no changes happen to the database, the entire build fails. And that's when developers have to come into play, then figure out like, why did that happen? So that was an example of how, kind of like an optimal way of how that would work in Python world. We're very much, most of our code is running is in Node. And with Node, we're still working through the issues of like, what is a good tool for generating these migrations, and then more importantly, how do you very robustly play these migration scripts out and have the ability to roll back and to detect errors. So we're working through some of that process right now.
Yeah, that was exactly what I was thinking about. Is we've kind of touted ECS's ability to make it super easy for you to have 100% uptime updates to applications. But if the updates to the applications include breaking changes to a database schema, that gets a little trickier. There's like, everything has to be kind of run in phases where, okay, we can change the database to add a bunch of stuff that's not going to break the old code. And then we can run a script that's going to migrate some data to some new tables, still not breaking the old code. Then we can put in the new code that sees those old tables, and then finally pull out the old code and get rid of any tables or columns in the database that we don't need anymore. So multiple phases of doing things. And I haven't seen, or I'm not aware of, a software tool that just takes care of all that without having to really think through it carefully.
Yeah, and if you do come across that, let me know, because I will buy stock in that company, because it's a super difficult problem, because it really is. It's at it's kind of at your architecture level. Like, are the changes that you're doing to your database schema, is it affecting? Is it backwards compatible, right? So, like we talked about how ECS, we may, for redundancy reasons or skill or performance reasons, have 4 instances of our microservice up and running, right? So 4 duplicate copies. And when we go do a new deploy, we're going to do a rolling update of those, right? So we're gonna individually kill those old versions and bring up new versions. So you're going to have a mixture of, some is the old code, some is the new code. But first, before you can run the new code, you have to change. If you've made database changes, schema changes, you have to run that migration. Well, if that migration is not backwards compatible, what happens now with the old code that's still running as it goes through the process, right? So it's definitely a very, very complicated. It can be very, very complicated, and usually big database changes are very difficult to do.
Agreed. So yeah, I guess we don't have the solution there yet. We don't have a tool in our CI/CD pipeline that solves that big beastly problem. But so I know what ORM are we using? Or Is there anything we've sort of settled on in the Node world that kind of relates to this problem, or is our current tool of choice in the CI/CD pipeline world of managing this stuff?
Yeah, so in the past with Node, some of it has been just kind of bare SQL. We're now transitioning more towards using SQLize as our ORM in Node, and so SQLize is probably the most popular ORM technology for Node, and it does have the ability to generate migration scripts as well. It's just the executing of those migration scripts in a very robust way are issues that we're still kind of working through and making sure that works. And there are other tools in Node. There's things like Connects and other technologies out there for doing that. So it's not like there's no answer to this. It's just that we individually, Kelsus, are still working through that, what that process looks like, and do in a way that's smart and robust, and that we're going to be happy with.
Right on. There's one other thing that we did recently to our CI/CD pipeline that I think might be worth talking about a little bit, which is we made some changes in order to support hotfixes. Because when you're running code in production, sometimes you need to fix the thing that's broken in production before you worry about any other thing. So can you tell me why we did that and what we did and how it impacted our whole process?
Yeah, so I mean, this is definitely one of those things that comes up with any kind of development team. Is you've got this process of developing code, and you have environments like development, staging, and prod, and you have feature branches, and so there's code is in many different places, and it's definitely important to know like what code is deployed where. So what happens? Usually, you work bottom up, right? You work like you're in the development branch, you're in a feature branch, you're working on some code, and then when you're done with that, you merge to development, and then as it goes through testing and integration testing and verification, then you now merge it into staging, and then once that's been tested and verified and you're ready for it to actually be deployed to production, then that's when it goes into master. Well, what happens when something makes it all the way to prod and now some perhaps critical error happens with it? There's something has been discovered that only occurred it was only discovered in production, or maybe it's something needs to be changed very quickly because you realize that we really this color should have been red instead of green, or like we need to change the label of some text or something because the customer has changed their mind. So you need to make a change very, very quickly. And so for that, you need to kind of now work from the top down. So you're now going in a different direction where you're going to actually make the change at the highest level, and then you need to make sure that change now gets propagated back down into the lower branches. And so that's kind of roughly how that process works for us, is that we just have a way of kind of knowing which where to start with that hotfix that's in the production code. So we're going to take a branch off of master. So you can think of it as it's a hotfix branch off of master, make our change into that, merge that back into master, and now have our build made from that, and we can now deploy. So something that's very, very quick. And then once that's done, then take that change that was made and merge it back down into staging and then into development.
And does that hotfix branch bypass the integration testing that would happen otherwise?
No, all that still has to go through that same process. It still has to be built on the build machine, Circle CI. All that stays in place. So the only thing that really changes here is just what stages it goes through as far as like the environments, if you will. It doesn't go through dev and it doesn't go through staging. It's basically you're going straight in production.
Right. And what this is making me realize is that our Git flow process is really the orchestrator of everything. Where we put our code and when, so putting it in feature branches, putting it in dev, putting it in stage, those branches are what kind of controls our whole CI/CD process. So it orchestrates everything, and then Docker images and then running Docker containers are the output of the process.
Yeah, absolutely.
All right, so let's just kind of take a moment here. I don't know, is there anything you felt I left out, Chris or Rich?
I have a few questions that are a little bit more meta that I think might be interesting.
Sure.
So what percentage of a project budget is spent on the testing and the CI and all of this infrastructure that the client really has no sort of like deliverable?
I think it totally depends on the client and how much they value those things. So we've been very fortunate at Kelsus to work with clients where they know that there is a lot of value to this. So even though it's work that is not contributing to like a very specific feature or materially changing the capabilities of the software that we're delivering, they know that it's an investment that will almost assuredly lead to higher quality software and also reduce overall development costs, right? By having those techniques in place. So as far as how much to spend, like what percentage of a budget, a lot of this, the tool chains and things like Circle CI make it really easy to get like this, these things set in place. And so it could end up being as little as 5%, 10% of your time of your developer time to have all this stuff in place. You can have more tests and increase your capabilities there with more coverage and more bells and whistles. Have like dashboards or better code coverage, reporting and metrics into the system and whatnot. And so you can definitely spend upwards to there, but it doesn't have to be a huge investment to get a lot of gains from it.
Another thing, such an interesting question too, because business-wise, there's a real conundrum, which is when you start to work with a client or if the business, so if you're not a consulting company like we are, but you're a business that produces software, if the business doesn't understand the value of these things, then what can happen is that when you first begin a piece of software, you may actually be able to produce the software quite a bit more inexpensively by not doing all of this stuff. So to get from 0 to 1, you might be able to cut all these corners, not do any of this, and just write code and deploy code somewhere. And maybe you can do that for 30% less or even 40% less, just kind of depending on how much rigor you put into building a DevOps infrastructure than you would without it, right? So way more cheaply. But then once things are going and once you have a lot of code, Chris kind of threw out 100,000 lines, and that is kind of a good number in my mind. It just feels about intuitively right. It's like enough code that you can't remember it all. There's like a dark corner in it somewhere that you haven't looked at. If you're the one developer, there's at least a few dark corners in it that you haven't looked at for several months once it gets to be that size. So once it's that size, there's also probably some interactions across subsystems that you might forget, and you're going to start making mistakes, and it's going to become harder and harder to add new features. And if you haven't gotten any of this in place, it's just classic what you just see as development teams grind to a halt. And then all of a sudden people are having meetings with the business about velocity and why it's at essentially 0, and why is all the time spent doing bug fixing and not spent working on new features. And so it's like, wait a minute, we did all this work and it was all so fast and it was all so cheap, and now all of a sudden we can't get anything done. And it's because none of this compounded interest on the investment that you should have made is not there. And so that's why it's worth spending a little bit more upfront to do this and to engineer it right. Because when you have to add this later, it's really difficult pill for the business to swallow. Really, really painful. I've never seen a business happy to just take that on and watch several months go by with no new features.
Yeah, I've heard this conversation a million times where the developer will say, in order for me to get out an MVP, I'm going to skip testing altogether. And then, that same developer seasoned like 18 months in says I'll never, ever, ever develop without TDD ever again.
Right.
My other question is, what can't you use automated tests for? And how do you use sort of like manual testing? So either like through QA once it's in production, or maybe that's even in staging, to make sure that the user experience or performance or things that a tool can't really pick up on.
Yeah, there is a lot that you can automate, especially if you devote the resources to doing that. That said, a lot of the times, things like UI testing are definitely more difficult to do in an automated fashion. It can be done, But it's definitely much more of an investment, and so a lot of teams will kind of do that in a more manual fashion, or use some of the other services that are out there for doing that. More kind of abstract things, like sometimes like just the overall correctness of like how well does this conform to spec. That's not something that you can do in an automated fashion, right? If you could, then I think you could probably design a system where you wouldn't have to write any code, I think. Right. So,
Yeah.
so there's that aspect to it. There are sometimes integration testing can get to be pretty complicated, especially when you've kind of gone into microservices as an architecture. The whole kit and caboodle, and you have many different services all interacting together. So that may be an area it's harder to automate. But the truth is there is a lot that can be automated. It's just how much time and effort you have to balance it out, right? It's a very pragmatic decision. Like, how much time is it going to take me to automate it versus how much time is it going to take me to just do it with manual processes. There's also something to be said too, like a lot of companies now, especially in Agile and CI/CD, is basically let your users do a lot of your testing for you, right? And so that's that continuous deployment, having canary releases where you have a new build and it only gets diverted to a certain portion of your user population. You monitor how that's working, and as if your monitoring systems are not detecting any issues or problems, then you can increase that percentage of deployment to go up until it's 100%. So there's techniques like that as well.
Great. Well, I guess we can wrap it up. I think that just looking forward, I'm excited to do this talk at GlueCon, because I think this conversation showed that there's a lot to talk about, and we're on. It feels like we're onto something in terms of having a well-tested and working CI/CD pipeline that we can share with other people.
Yeah, for sure. And it's like for me, it's I think we could probably dive deep into I think there was 6 or 7 different topics we could have gone much deeper into. So like I said, Definitely very interesting. This is one of those things where kind of everyone knows they should be doing this. I think that's writing software, but in practice, it's really hard to do in practice, right? So to actually kind of break it down a bit, and to kind of talk about a little bit about the practicalities of how to do it, as well as the motivations behind it and what benefits you get, is very, very interesting.